Now we gotta do the procedure, I suppose.
Okay, does that make sense, by the way, firstly? Does that make
Yeah.
sense why I made you write an A?
Yeah.
Cool, perfect. Now, next step I would do is I would write my equation.
Okay.
Yeah, write out an equation. Give me an equation. So do you want to write it down on our whiteboard?
Yeah. Okay. So we've got.
Okay. So let me just get a textbook out. So next you would do. So you're gonna have your aim, which is we've already stated. Then I'm gonna have my equation, which is CH3C or my this one acid, and remember you need
plus
subscripts.
sodium hydroxide.
Again, subscripts. If you don't have your subscripts, I'm gonna get mad. So will your teacher.
No. We'll not forget that.
Anyway.
And
then you're gonna have your salt.
Yep.
I could spell things properly. So again, aqueous plus H2O.
Yep.
Ta-da! Very easy. See, that took us like literally 30 seconds to do. Yep. So aim, we've stated, this is what we're trying to work out. That's really important because when your teacher's going to mark you, she's going to be like, okay, so this is your experiment. You've used two types of reactant. You had a weak acid and you had a strong base, and you're showing her it was a neutralization reaction. This is the salt you got, and you also got water. Do you understand logically why it makes sense?
Yep, just to set things out and to have it all clearly explained what you're doing.
Yep, perfect. Now, let's talk about the next step. Next step is you need method and materials, yeah?
Yep.
Cool. What are your materials going to be? Are you guys, let me see if you guys are getting that.
We'll probably, I think, no, we have to choose. I'm pretty sure we have to choose what we're going to use.
Okay, do you want to do this in dot point form quickly? We have time.
Yeah, may as well. But yeah, I think we'll be going over this next week in class. What exactly you use for titration. So
okay,
we can just do it now anyway.
Yeah, we quickly will go through it because it logically makes sense if we do it step by step. So when you're going to go into class, you're going to know exactly what she's talking about and you're going to be on point.
Yeah.
All right, perfect. Okay, so you agree you need a burette and you need a conical flask.
Does it say what concentration our sodium hydroxide is?
Let's have a look. Okay, so you use the volume of your titer.
Oh yeah. Oh yeah, it's 0.1 molar.
Where did you read that from?
In section 2, analysis of data. It says following account of titration written by each student.
Okay, actually, quickly, before we do your...
Actually, I don't know that. That's the one that's like an example, I think.
Yeah.
I don't know if
Before you do your methods materials, the next thing your teacher wants to talk about is your risk assessment. So your materials used and the risk. Can you see the table?
Oh yeah.
So you're going to talk about like you've used a burette and you've used a conical flask, which is glass. So your hazard is glass. So therefore your risk control is going to be carefully picking things up. Do you agree?
Yep.
Same with, again, your next material. Are you writing this down, by the way?
It says on this sheet, it has underneath risk assessment, it says choice of equipment.
Material used.
And then, yeah.
Yep. So then you talk about your acid and base, how that's corrosive and.
Yeah, I think we shall when I actually do this, I'll have it set out that I don't want to necessarily use these sheets. I can just do it in a better format. And that has all of this.
If you this format, if I was you, I'd be using that format.
All right. I suppose we could.
Because she's the one marking it, remember?
Yeah. Concentration of vinegar.
I'm trying to find the concentration of your sodium hydroxide. This is what I'm not liking.
Yeah, I don't know.
Because I can see your marking scheme makes sense. You've got three. You need three. You guys need 3 risk assessments. You need 3 hazards.
Yeah, there's room for 4, so you can have 1 for the acid, 1 for the base, and 1 for some glass, maybe.
Okay, so your equipment use is really important, so we need to go through that because it's 12 marks. Out of 50. Like that's a big chunk. So You understand you would use a pipette, you use a burette. Yeah. You're going to have a burette stand.
Yeah.
Okay. Look at your phone. I'm going to send you a photo.
Burette stand, conical flask.
Ta-da. Have a look at your phone.
Is that a list already? Let's see. Uh-huh. Uh-huh. Is that standard titration equipment,
That's
or is
pretty
that
much
one?
how you, this is how you want your titration to look visually. So as you can see, firstly, you've got your stand. That's the first most important thing. You've got your 2 types of clamps, can you see, to attach to the pipette, to the stand.
Yep.
Cool. You're going to have your burette, and it's important that you're going to pick a burette that's for 50 mils. That's something that can trick you. Not 100, pick 50.
50 mils, okay. 50
mils, pick a 50 mil burette. And then you're going to have a conical flask. With conical flask, you can do whatever you want. You could do a 250, a 5, a 2. I would say go with a 200 or 250 because you want enough space to fill everything up and you still want to see what's going on, but you don't want it too big where you're trying to get every single dot into the solution. Does that make sense?
Yeah, so 200, 250, something like that.
Yeah, something like that. That would be me, what I would use. Next thing is, can you see that you're gonna need, as you said, a white piece of paper or white tile to see when the color change occurs?
Yeah.
Yep, that's important. You're also gonna have to have a wash bottle because you're gonna have to be if you're gonna put a drop from your burette into the pipette, you're gonna have to wash it off so it actually doesn't go to the glass, but it goes into the solution. Because like a mil or half a mil can change phenolphthalein indicator from being light pink to fuchsia.
So you want to make sure you have something to
wash it down.
Off.
Correct. You need to constantly wash things down. I will tell
sorry,
you,
what are we washing? Sorry, which part of it?
The glass. Remember, okay. So you've got your conical flask. You're going to be washing that down inside with a water bottle, not a water bottle, but like a water. What do you guys have?
Yeah, like a distilled water.
Distilled water. Yeah, that. I'll tell you this. I was an idiot my first day at uni. I had to do a titration. And I didn't water anything down, like I didn't wash anything down. I was just literally putting in drops. But some of my drops got stuck onto the conical flask, like the glass wall, not into
that happens.
And then I went from being a nice light pink to a freaking like bright, like this color, like in one drop. And I failed. Right. I failed my titration. So learn from me. Get a distilled water bottle and constantly wash it.
Yeah.
So learn from my mistakes. Don't make the mistakes I made. Please don't.
Yeah.
Okay. You're gonna need, when you're pouring, this is something to do with safety as well. When you're pouring your solution into your burette, you need to have
that's a funnel. Yeah.
Yep. You agree with me. Have your funnel. That's really, really important. And of course, you're going to need 2 beakers. You're going to need a beaker for your acid and you're going to need a beaker that's filled with your base. Do you agree with me on that point? Perfect.
Yeah.
Cool. So that's what I think. Oh, and you need your indicator. Remember, 3 drops. 2 to 3 drops, not 2 more, not less. Otherwise, you're going to screw up your the amount.
Yep.
Okay. Is that making a bit more sense?
Yeah. Yeah, I think so. H2. Yep, I'm good.
You good? All right, do you want to let's do the step-by-step method, yeah?
Yep, okay.
Okay, so what you would do, firstly, you agree with me, is you're going to wash your 2 beakers with a bit of the acid and a bit of the base, each one.
Okay, let me just quickly do that. So I write method.
Oh, so I could probably, do you want me to type as well? Would that be easier for you?
Yeah, that would be easy for me, yes. So I don't have to do it.
No, you're still typing with me because I'm slow. No, you're still typing. Come on. Okay. It's just I'm filling in the gaps that, the ones that you make. Okay, step 1. Remember, as we talked in the materials, you're going to have 2 beakers. One's going to be with your acid and, oh God, see, this is why I don't type. One with your base, yeah? What you're going to do firstly is you're going to take both of the beakers and you're going to wash them with what you're putting in them. So beaker 1, wash it with a bit of the acid, pour it into the sink, and your second beaker, beaker 2, wash it with a bit of the base, yeah?
Acid to... Yep.
So rinse, in theory, rinse beakers. Also, get beakers that are about 150 mils, not more. Otherwise, it's really hard to get things from them. So 100 ml beaker, rinse that beaker with the solution that is going to be in the beaker. Yeah?
Yep.
Perfect. Does that make sense?
Going to be in the beaker. Okay.
Right, step 2. What you're going to do is now we're rinsing again. So you're going to rinse your burette. If I could spell burette, how does burette? Oh yeah, here's burette. Burette with the solution. Okay, what you're going to do firstly, can you hear me? Is you're going to close your tap of your burette. Okay, let me just write that down. So close the tap of the burette, close tap, and you're going to wash it with distilled water. So close tap of burette and wash inside with distilled water.
Yeah.
And allow that water to run through the tap. Does that make sense?
Yeah.
Because firstly, you're going to close the tap, fill the whole burette up with water, or not whole, just halfway, mostly through it. Circle it around, and then let the water out through the your little tap. So you
fill it up and then open it. So you can. Yep.
Yeah. So remember, use the tap. Yeah. So close the cap of the burette. The cap. Oh my god. The tap of the burette. Wash inside with distilled water. Empty via the tap.
Yep.
Right.
I actually have access to RO water instead of distilled water because it's kind of better, isn't it?
Doesn't just use distilled.
Yeah.
All right. Does that make sense?
Yeah.
Okay. You've done that. Now, what you're going to do is you're going to slightly rinse with what you're going to put in into your rinse with the solution going into the burette. Yep. So what are we agreed?
So rinse the burette with the solution.
Yeah. So that's going to be. You need to double check with your teacher if she wants you to put the NaOH or your acid or the acid into the burette.
Because usually you put acid into base, not base into acid, because generally is a safety rule, even though they're weak.
Okay.
Well, it's still a weak base. I mean, it's a strong base, but yeah, I don't know. I generally do.
Okay, we'll put NaOH then, yeah?
Yeah.
Wash it with that. And then finally, step 4, fill it. Fill it, so...
Fill. Do these specific amounts of how much you fill your
when
with,
washing,
is that important?
When washing, doesn't matter.
But just when we're filling it now, how much do you put in? Do you fill it up to?
Yep, that's my next thing. So fill your burette. So remember, we talked about this. We're taking a 50 ml burette, yeah?
Yeah.
Perfect. So you're going to fill your burette 50 mils. And in this situation, remember, you're going to be using you're going to close your tap and you're using a conical flask when transferring your base from your beaker into the burette.
Yes.
Perfect.
Yeah. Fill burette using a what is it called, a funnel.
Yes, you are. Oh, yeah, funnel.
Yeah.
Perfecto.
Cool.
Does that make sense? And what's important to note is I'm going to send you another photo. Have you learnt about meniscus? Have a look at your photo that I sent you, just quickly. And then there's a bubble image. When the person has filled up the burette, have a look at it quickly.
Yeah.
Can you see how the meniscus, so the bottom of the bubble its bottom is at 50? That's how you know you've got perfectly 50 mils.
So it's where the bubble is.
Yeah. Can you see that? Like, if you can make the photo bigger, as you can see, this is what I'm showing you right here about this.
Is that super important?
Extremely, because
do you need exactly 50 mils to do
absolutely,
this?
Absolutely, 100%. If you get something more or less, that's gonna throw off your whole thing.
Oh shit! Okay.
This is like, do you know how you're cooking? How people say this is like your important point, or this is like your, I don't know how to put it together. Your pressure point.
Cooking. If you screw something up, usually you can rescue it with cooking skills. I don't know.
No, you can't.
But like
if it's burnt,
you can't.
it's burnt. Honey.
Yeah, I mean not that far. Like if you cook it slightly too much, like it's still going to be edible. But this is stuffed if you do it like slightly too much.
As my fam would call it, this is like a master chef pressure point. This is a pressure point. Like we've been talking about so far, it's been quiet. This is where I want you to focus. That's why I sent you this picture. You've got a beautiful clear. So imagine this is at 50, that line right here, the biggest line. You want your meniscus to be touching slightly that 50. That's when you know you've got 50 mils.
Yeah.
All right, perfect.
You could weigh 50 grams and then just.
You don't have time for that, Heath. This thing is timed. You don't have time to do that.
Okay.
So it's just easier. And this is my tip for you. If you see you're under or over your meniscus, just get a plastic. Do you know those pipettes?
Yeah, you can take it out with that.
Correct. Just play with it until it's perfect. It might take us 2 more minutes extra, but it's worth it.
Yeah. By the way, I have 2 hours to do this. So.
Yeah, but dude, trust me. I've done titrations. They take time.
My teacher said, yeah, we got a double period to do it. So.
All right. Does that make sense? We filled it up. I hope to degauge the meniscus. Got that sorted.
Yeah.
Okay. So you filled it up. So when you filled it up, you're gonna have it clamped. Does that make sense? I don't have to. Does that make sense logically?
Clamp the funnel. Do you have to clamp the funnel?
No, not the funnel. The burette. Remember, clamp the burette.
Yeah.
That makes logical sense. Yeah. So burette is clamped. Clamped to the, what do you call that, stand? That makes logical sense. Come on, if it's not clamped, how the hell are you going to do it?
Yeah. This isn't this isn't science from year 7.
Well, I'm trying to
make assumptions.
Well, I'm trying to be as clear as possible, okay?
Because in science, in junior science, they were like, you have to say every single minute detail what you have to tell them to do. But
this is what I'm trying to do with you right now, because I want you to get, out of those 20 or 50 marks, you're getting 50, or you're getting at least 45 above.
Yeah.
Okay. Do you agree, as you say, this is year 7 science and I'm being baby, but you're...
No, I'm saying we're not being that, but like people, they used to be.
Your burette has to be vertical. Trust me, the amount of times I've done my freaking lovely titration and my burette not being like vertical, it being a bit off, which means I didn't have enough 50 mils and then it screwed my whole thing. So I know I sound really pedantic, just eyeball and be like, okay, that kind of looks vertical, cool, we're good to go. Does that make sense?
Yeah.
Perfecto. Okay, so you filled it up, right? You're going to remove your funnel, you're going to check your meniscus, you're going to play with that until you are happy with it, yeah?
Yep.
Whew, okay.
This is what chemistry students talk to like at the end of their titration, they're talking about all these little details.
Oh, I had to do once. My final last year for chemistry 1 was a titration exam, and you got 2 periods, right? You got 2 hours. My teacher was like, here's 50 minutes, and you have to like do the like crack 4 times. Like she wanted 4 results.
That's holy shit. That's like, did you set them up simultaneously or something?
No, I had to do it individually. So I had 10 minutes to set all that up, and then I'll get one reading, throw everything out, wash everything out, do it again, do it the 3rd time and 4th time. So I was like, I'm not joking, like 30 seconds in her being like, hands, tools down, hands off, I was still writing down my results from my 4th titration. So you're getting 2 periods. You're good. You're chill. All right. So remember, with titration, you're going to be doing it 4 times as well. You're going to have a rough, you're going to do it, and then you're going to have 1, 2, and 3 being perfect. You agree with me about that?
Oh, do we have to do it 4 times?
Of course, you can't just do it once. You're trying to remember, she's going to test to see if your results are accurate.
Yeah, you probably should do it a couple times.
Yeah, so to me, I would do it a rough titration, which is where you can go silly and just open the tap and just watch it pour. And then your 2nd, 3rd, and 4th is where you're going to be pedantic and you're actually going to use a pipette.
Yeah. Okay.
Okay. I feel like I'm losing breath. All right. Now, let's set up your acid. So what you're going to do is you're going to fill up your lovely beaker with acid. Do you agree?
Yeah.
So step 5. Hello, computer. Step 5. Fill beaker with acid. Yep.
Yep.
Step 6 is, again, you're going to wash your pipette with your acid.
Hmm. Did yours just these 2?
Pardon me?
Oh, sorry. PIPP. Okay. Yeah, because my dad's like mad into fish tanks. We can make our water out the back in using his filter.
I don't think your teacher, I don't know if she'll allow you to do that. I don't know if she's going to be very happy you bring your own substances to your chemistry exam.
Yeah, maybe not.
I don't think you should do that, just FYI.
Yeah, probably not.
All right, so you've washed your pipette, right? You washed it, you filled it out into your like sink or whatever you're going to have, your storage emptying container, and then you're going to fill up your pipette with 25 mils, yeah?
Yep. Oh, wasn't it pipette with 25? Wait, which pipette is this? Is this the pipette you're putting in your indicator with?
Your acid to put into your conical flask.
Oh, yeah, okay.
Because remember, you can't just pour it. You need remember, chemistry is pedantic. You need exactly 25 mils. So that's why you're going to use a pipette.
Yeah, like the screen's frozen, by the way. Like, you didn't finish writing something.
Yeah, I know.
Okay.
I told you I'm terrible at writing. I'm good at talking and explaining. I don't know how to wash it. Oh, not peptide. That's metabolic biochemistry. Wash. What was I saying? Pipette.
Do you do biochemistry and
Yeah, I'm doing
chemistry?
it this semester actually.
Is it part of a biology course or something?
It's part of chemistry actually.
Oh, do you? Okay, that's cool.
Wash pipette with acid firstly, and then fill pipette. Fill pipette with acid.
Fill with 25 mils?
Depends what, I think, let me double check. I think it's 25 mils. You need to ask your teacher how much mils you guys get.
Yeah, it doesn't say exactly how much of each thing we get.
You need to actually ask her. Can you ask her on Monday?
Yeah, well, but wouldn't we be able to work this stuff out for ourselves?
No.
I think they'll have specific amounts that they will give us.
Well, hopefully. What my teacher did, she gave us 2 liters worth of everything, and she was on good luck.
Yeah, my teacher will probably do that too. Let's be honest.
Okay, so let's just say in theory we're putting in 25 mils. So I put it in brackets.
Yeah.
So we're going to put 25 again. In your pipette, you're going to be looking at your meniscus. It's painful, I know. Look at your meniscus. Because if you're above, you're not putting 25 mils, you're putting 26 and a half. That's going to throw off your whole thing, and your teacher's going to mark you wrong.
Okay. Yeah.
So look at your meniscus. Yeah?
Yep.
I don't know if that's clear enough.
Yeah.
And that's my case for meniscus.
Did you do a similar one for your exam?
What do you mean?
Did you do a similar one for your when you Like, did you do the same one or something similar for your exam?
High school or uni?
High school.
High school. I did have to do a titration exam as well, except Miss Rennie. You didn't go to Gospel High. My teacher was really, really nice, and she literally went through the method step by step in class the day before the exam.
That's nice.
She literally was like step one, like how I'm doing it to you right now is how she did to me, and because of that, I was able to get like a really good mark out of it because I literally knew exactly what I was doing. Like,
Didn't everybody have that though?
Pardon me?
Didn't everybody have that as well, though, that advantage?
No, because the class next to me, Miss Boy's class, she just pretty much was like, Google it.
Uh-huh. Yeah, okay, that works.
So I think we had the advantage because our teacher was nice.
Yeah. Some teachers go to the next step, don't they?
Yeah, mine did. So I was very happy because I got a really good mark. So I was happy for that semester.
We're trying to in my class, we're currently trying to, there's a few people that have left, and those are the people that I would drag down a bit.
What do you mean
so
left?
It's good.
Like drop out? Isn't it?
Yeah, or drop a subject that if they haven't already dropped one, or move a class if they really have to. It's pretty late, but on the same line is investigating science, which is like the old senior science. So a chemistry student probably could move to that class and make it through.
I would not want to do that.
No, not I.
Anyway.
Like this. Yep.
All right. So that's what you've done, right? What you're going to do then is you're going to put your pipette, as you say, logical. You're going to put what's in your pipette into your conical flask. Bear in mind, okay, step 8, your conical flask has to be washed with distilled water.
Okay.
So conical flask washed with distilled H2O. And then 9, fill your conical flask with the contents of your pipette.
Yep. With the 25 mils of acid.
Right. So congratulations. We have set up, basically, nearly. Step 10. Oh dear God. I'm starting to not have enough space. Step 10 is we're going to put your indicator.
Add, what was it, for 3 drops, was it?
2 to 3 drops, depending how big your pipette is. If you're putting big drops, you can, as you said, this is where you use your logic. If you can see you're putting if you're putting little drops, put 3 in. If you're putting big drops, put 2 in. Not more. So 2 to 3, I wrote that, 2 to 3 drops. And remember, you're using phenolphthalein.
Yeah. That's hard to pronounce.
Phenolphthalein. So you're using that.
Phenolphthalein.
Alright?
Phenolphthalein. Yeah.
Okay, step 11. We're nearly there. This is where, as you say, I'll get a piece of paper. My teacher was really cool. She got us white tiles, but you might not have that. So put a white piece of paper or tile, anything that's white, so you can see the color change occurring. So white piece of paper, white tile under conical flask. That's what I would do. What else would I do? Other thing is, do you understand? Okay, look at my hands because I don't know how to write that down. Just beware that let's say the end of your bread is in your conical flask. Does that make sense? So the droplets aren't going 3,000 miles; they're going quite short. Does that make sense?
Yeah.
So, because you don't want one drop to go onto the floor. Does that make sense? Or onto the tile. You want everything to go into your conical flask. So be smart about that, right? Be logical. So have a nice distance where you can still swirl your mixture, your conical flask, but have enough, not have a small gap where you're not missing any of the drops going onto the tiles. Or
So you want to be able to pick up your conical flask without it taking the burette with it?
Correct. Okay, so imagine this is the neck of my conical flask, right? I'm going to want to pick it up. I'm going to do this, but I want my burette to be, let's say, about there, like this.
Okay.
So where I can see up. swirl, put down, let's go.
Yep.
I think that would be the way I would do it.
Yep.
Okay, well, other than that, this is where you start. So we've set everything up. Now it's time to start doing the experiment. Your first one, as I said, this is really important. You're going to do a rough titration. This is where you go loose. You can just open the tap, go for it. Just see when it turns pink. When it starts turning pink, that's where you be slow. So you have a rough idea. Let's say it's 24 mils, 24 to 27.
So you'll need to do your, you need to be filling your, you need to refill your pipette with acid and redo all of that over and over again. Like
well, yeah,
when you do it each time.
Correct, you need to top up.
Yeah.
Because remember, you're starting from 50 and going onwards.
Yeah. So do you reckon with your test, not worry about this one, not worry about like measuring out 25 mils. Don't worry about making sure the it's precisely 50 mils in the purette, like when you're doing your test.
You still need to have that precise, because remember, your rough is giving you an indicator understanding as to what's your range. Because your rough is being like, oh, it's between, remember, it's pedantic. So your rough is going to be like, oh, it's between 24 and 26 mil. And then using your first titration, you're going to be like, no, it's actually between 24 and 25. And then your second and third titration, it's like, no, it's actually 24.5 or 24.7. So no, your rough titration is really, really important, because you're going to know what's your ballpark. What are we heading at?
Yep.
Does that make sense?
Yeah, it makes sense.
Cool. So you're going to redo it 4 times. Well, rough, then titration 1, 2, and 3.
Yep.
Cool. That's pretty much my methodology that I used when I did all my exams in terms of titration.
Yep.
So yeah, so we've gone through risk assessment. You know what you're going to write for your risk assessment, right? So acid, glass, blah, blah, blah. Yeah?
Is sodium hydroxide dangerous in any kind of way?
Absolutely. It's corrosive. It's a base.
Yeah, that's true. It's not that corrosive though, is it?
Hey, we're trying to get marks here. You're going to say it's corrosive.
So, yeah, so you don't want it. You don't want to drink it, and you don't want it to go in your eye, basically.
Yeah. So you're going to wear goggles for that.
Yeah.
Yeah. All right. So we've talked about risk assessment. We've talked about your equipment. I'm going to send you a photo of what because I typed it out. I've talked to you about it, but I've typed it out. So if you get confused, you can just have a look at my sheet.
So have I. I've typed it out what we've been talking about.
Perfect. So now your next part is concentration of vinegar calculations. So remember last week we actually did a calculation?
Also, this setup, you don't actually explain how you do the actual how you do the actual titration.
Well, you need to ask your teacher if she wants you to write out a method.
Yeah, she says procedure, but that doesn't necessarily mean
that's method.
Like,
dude, that's method.
Yeah.
That's method.
Yeah, but it says that's right. That's what I'm saying. Like we have it says to do a method. So does it want the entire thing?
Yeah,
like the entire step-by-step process.
I think it does. Do you know what? Not next week, but the week after, we're going to sit down and we can totally smash out an aim, a method, and a results in 60 minutes.
Okay, cool.
So don't worry about that.
Because we have you won't be here next week though. So.
No, because that's why I said next 2 weeks. Because yeah, next week I have an exam. I won't be in Gosford.
Actually, yeah, we could actually. You know how instead of on that night, that night we have in the next like in 2 weeks, like before it's due, we could do like 2. We could do 2 or 3 hours because we got to catch up on those.
So no, not 3 but 2. Not 3 but 2.
Yeah, we could do 2 hours instead of doing 1, so we can catch up and at the same time smash this out perfectly.
Sure. So on the 26th, let's plan that we're going to spend, let's say, 2 hours writing the report.
Yeah.
Cool. That's a plan. All right. So let's continue. We've got 10 minutes. So let's continue. So.
Trying to quickly do the what's this head? Do the calculations to concentration of vinegar.
Yeah. So what I was going to say, we can do the calculations together not next week, but the following week. But what I do want to how do I put it? This is how I want you to present your results. I want you to make a table. Firstly, I'm going to send you a photo. So go on your phone so you can have a visual example of what I want or what you should do. It's not what I want. I want something like this. So, as you can see.
It's not come through yet. There we go.
Okay, cool. Can you see that table?
Yeah.
That is how I want you to write your results. I want your columns to be rough, first, second, and third titration. And then
second reading.
Second and first reading you probably don't need. You're probably just gonna be saying how much of your oh brain please work. How much of your burette you've used, how many mils?
Yeah. As your leader.
Your title.
Or is that your title? What does title mean?
The amount of used in your burette.
Okay. Centimeters. Why is it in centimeters cubed?
So that's probably how I would pretty much set it up. So it's really clear, being like, okay, rough, first, second, third, and this is the tighter.
Okay.
And first and second reading is just pretty much being like really pedantic. You're like, okay, so the first time I looked at my meniscus, it was 26.2, but now I'm looking at it again, it's 26.4. So that's what they mean about the first and second reading. I don't think
so you're saying for your leader, so you're reading, by your reading, what are we measuring exactly with the readings?
What do you think? Let's think about it logically.
Is it the what's it called? The amount of acid, or is it?
How can you measure the amount of acid if it's in a chemical flask and there's no formal measuring?
Or is it?
Meaning no.
Are we trying to get it? Like, are we measuring when we get like how many mils we've used to get it to the what's it called? What's the name of it?
Okay, to make life a bit more easier, what you're going to do is okay, this is where you need really good eyes. You're going to know when you're finished, like your first, let's say, titration, your rough, is when your solution, meaning your acid in your conical flask, is going to be the most lightest pink possible. So not when it gets to this, the lightest pink possible. Does that make sense?
So is that before it goes darker slowly and then it's...
You don't want it to go dark. If you've done dark, that means you've overshot the equivalence point.
Yeah.
You want it to be the lightest. Like if you Google you should do something like your own research. But if you Google titration perfect, you're going to see that when you're using phenolphthalein, you want it to be the lightest pink possible. Let's see if I can do it. Actually, let me Google it. Let me show what I'm talking about.
Yep.
So titration, that's what you want. And when you've done that, you're going to straight away have a look at your burette and as to how many mils from 50 you've used of the base.
Yeah.
Write that down.
So you basically by visual, what you visually, you just look at it and then eventually you once it reaches that color that you're looking for, then you obviously you measure how much you've used to get it that way, and then you write that. Do you write that next to reading, like first reading?
All right, let me show you quickly. I've got a photo, and then I'll answer your question. Okay, this is what I'm talking about. Let me just share my screen so you can actually see what I'm talking about. Can you see this?
Yes.
Great. A, that means you still haven't had a reaction. B, that's where, can you see when you're putting even one drop, it changes color, but then it goes away?
Yeah.
That means it's very close. This is where you're going to need to use a pipette. You're putting in like 0.5 ml drops.
Yeah.
C, that's done. D, that's shit. That's not that's what I'm saying. You don't want it to go the color of my highlighter. That's crap. That means you've overshot the equivalence point and you're not neutralizing anything. You're just pretty much, you're making garbage.
You've made it more basic, haven't you?
So this is
You made it too basic. You've not neutral, you've gone past neutral to basic.
You've gone to God knows what. So B, this is really important. So A, if you're pouring your base into your acid and it's constantly white, great, keep going. I'll send you actually this photo because I really want you to.
So you open that tab for a certain amount of time, then you close the tab, then you use your pipette to do the rest until it reaches that little pink color.
No. Here. So if you open the tap, let's see if it goes like this. Also, you need to constantly swirl it. Do you know what I mean? You need to constantly swirl your conical flask. You need to constantly have it in your hand swirling. And if it's white like this, you keep going. You yawn, whatever. But if you can see where you're putting in drops, can you see how it goes pink and then it goes away?
Yeah.
That means it's really close. This is where you don't open the tap. You're just going to put little drops. You're going to open the tap slightly where you're releasing, like, say, like a drop of NaOH.
Yep.
Does that make sense?
Okay, so that makes sense. So once you get to that stage where it changes back when it goes pink and then back, you do that.
That's really
you do it
close.
delicately. You do it really delicately.
Absolutely perfect. You got that point. Correct. Because if you're getting to this point, this is not where you're opening the tap and letting it flow. This is where you're slightly opening the tap. You're allowing like 0.5 ml, little tiny drops in, and then you're going to swirl it. Because literally, what can happen? You can go from A to C in one drop.
Oh, okay. If it's really concentrated?
No, it doesn't matter about that.
So is it just the specific acids and specific base you're using? Is that indicate how long it will take?
The indicator. It's just the indicator changing color. Don't worry about that.
Oh, okay.
So yeah.
So some indicators are faster than others.
Oops, what did I just do? Uh-oh.
So some indicators more sensitive than others.
Different indicators are used for different like acids and bases. So in your situation, you're using phenolphthalein, you have a weak acid, strong base, you're using this. This is what's going to happen. You're going to go from A to C with one drop. So that's why B is your intermediate point. That's where you need to start freaking out and you need to start being really careful what you're doing.
Yep. Okay.
Yeah. And then D's crap. If you get D, start crying.
So you start again.
Correct, because that's crap. You can't use that result. That result would be an outlier and you would not use that as a calculation.
Yeah. Okay.
And you would do that 4 times. So your first one would be rough, meaning you're going to be like, okay, I got from A to C, let's say in 25 to 26 mils. Then your first, second, third, you'd be like, oh, I got from A to C within the 0.5 and etc.
So do you look at each time? So once you've got to that sort of half B, do you just you read the measurement of your pipette, then you take another drop, and then if it goes to C, then you know it's between half a mil difference.
Correct. So when you're at C, this is when you're going to be reading your burette.
Yep.
You can read it at B. That could be your first reading when you're at B.
Because you want to know your difference between that. So.
No, not really. You want to know what happened here. You're just
comparing between your different results.
You're comparing between different results.
Yeah.
So you're comparing, you did this 4 times and you're comparing your 4 Cs. So you're comparing this 4 times.
Yep.
And when you get to here, this is really important here. When you get to C, you're going to immediately read how much sodium hydroxide you use from your burette. So from 50, let's say you go to 20, that means you've used 30 mils. That would be your answer.